Welcome to today's GATE video. Myself S.A.E.C MP, Assistant Professor, Department of Computer Science and Engineering, S.A.E.C Engineering College. Today's topic related to data structure, tree traversal. Let us start. Tree, as you all know, tree is a non-linear hierarchical data structure used to organize and represent data in a parent-child relationship. Here it consists of root, topmost node, that is called the root, and every other node can have more than one or more child, that are called child nodes. So this is a tree. This is the root, and this is the left child of the root, and this is the right child of the root. So tree traversal, here traversal means visiting or accessing each node of a tree exactly once in a specific order. Unlike the linear data structure like arrays, linked list and queue, we can have the tree traversal technique in trees. There are of course multiple types of traversal technique used in tree data structure. So these are the types of tree traversal technique, mainly categorized into two data types tree traversal, that is DFS, that is the depth first tree traversal, and breadth first tree traversal. The breadth first tree traversal is otherwise called level order traversal. There are three types of DFS, depth first traversal. One is the in order, second one pre order, and the third one is the post order. Let us explain each one. First one is the depth first traversal. Here explores or visit as long as possible along a branch before exploring the next branch. So that is the DFS. Depth first search, it explores or visit along a branch before exploring the next branch. So when you consider these DFS in this tree, so this is the root node or the source node. In DFS means from 0 to 1 and next to 3, next you have to move for 4 and then you have to move for 2 and 5. Likewise you have to move for the DFS, that is the depth first traversal. So and the second one is the breadth first traversal, visit nodes level by level from top to bottom. From top to bottom we have to visit it. This is considered as the layer 0 and layer 1 and layer 2. In BFS it will explore from level by level, from top to bottom, that is from 0 first layer is completed and to the next layer it is 1 and 2. We have to travel 1 and 2 or visit 1 and 2, and the third layer is the 3, 4, 5. So BFS traversal is from 0, 1, 2, 3, 4, 5. That is about the BFS. So when you go for algorithm DFS, that is the depth first traversal, there are three types of traversal technique. One is the in order, second one is the pre order, and third one is the post order. So in order traversal, the algorithm, so in order of tree, traverse the left subtree. First you have to visit the left subtree, after that visit the root and traverse the right subtree, that is left root and right subtree. That is the algorithm for in order traversal. So let us go with an example. So first one, the first step, there is a tree with 1 as the root and remaining as the child nodes. Here first step we have to start in order. First step we have to start with 4. What is that is left node. So start with the left node. So first step we have to visit left 4, and the second step we have to move with we have to complete the left node. So 4, next one is the 2, and the third step we have to visit 5, that is the left, and the next after left subtree, here up to 2 the left subtree gets completed, then you have to visit the root node since it is an in order traversal. So 1, that is next one is the root node, you have to visit the root 1, and the next step we have to move to the next subtree. What is that? 3. And the last step you have to visit the next right subtree. What is that? 6. So up to this you have to complete. So all the nodes get traversed. So the traversal ends here in the node 6. So the next method is the pre-order traversal. Here in the algorithm for pre-order traversal is pre-order of tree. So that is, we have to visit the root node. Here you have to visit the root node first, and the second one traverse the left subtree and traverse the right subtree. So first thing, here at first you have to visit the root node. So in this tree, one is considered as the root node, that is the node 1 is considered as the root node, that is the initial traversal since it is the pre-order. And the second one is we have to move with the left subtree. We have to visit the left subtree. So from 1 we have to move to 2, and the next one is next third step. And third step, and third he have to use node 4, and the next fourth step, the next subtree is 5. So up to this fourth step, here the left subtree, the traversal of left subtree gets completed. And here traversal of left. So next one we have to traverse to the right subtree. So after that we have to move with from 5 we have to move with 3. Next finally we have to traverse the 6. So the traversal ends here in the system. So the pre-order traversal of this tree is 1, 2, 4, 5, 3, 6. This is the pre-order traversal of this particular tree. And the next third type of traversal is the post-order traversal. Here algorithm for post-order traversal, post-order of tree. What is the first one? We have to traverse the left subtree and traverse the right subtree. Next one we have to visit the root, left, right, root. That is the algorithm for post-order traversal. So the first step in post order, left, what is the leftmost node here? 4 is the, in this tree 4 is the leftmost node. So start from 4 here, that is the first step. Next traversal is next leftmost is the 5. So next node we have to here traverse 5, and the third step we have to traverse 2. Next leftmost is the 2. Then we have to move with the rightmost. Here from 2, after 2 the rightmost node is the 6th node 6. So we have to visit that node. And the next step we have next rightmost is the 3, node 3. This is the next rightmost. So after that we have to visit, since it is a post order traversal, after rightmost node we have to visit the root node. So here one is the root node. So here the whole traversal, tree traversal occurs start from 4, 5, 2, 6, 3 and 1. This is the post order traversal of the given tree. So the next method is the level order traversal. So level order traversal, here it visits all the nodes present in the same level completely before visiting the next level. So before visiting the next level, for that the algorithm is here we have to use a method called level order of tree. The first step we have to create an empty queue. After that, after creating an empty queue, we have to enqueue the root node of the tree to queue, loop while queue is not empty, dequeue a node. So we have to dequeue a node. We have to remove a node from queue and visit it. Enqueue the left child of the dequeued node if it exists, and the last step we have to enqueue the right child of the dequeued node if it exists. Likewise the algorithm will continue. So here first step we have to, so in this example first step we have to empty the queue. The first step we have to empty the queue. So in first step we have to empty the queue. So since the queue is empty, first step we have to empty the queue, and the second step we have to enqueue the root node in the queue. So here 5 is considered as the root node, 5 is considered as the root node. So first we have to enqueue. Enqueue means we have to add into the queue. So we have to add into the queue, that is 5. And the next step we have to, so here when you enqueue this element 5 into this queue, this will consider as the friend element. So next step we have to dequeue the friend element. So here the 5 is considered as the friend element, so we have to dequeue the friend element 5 from the queue, particular queue, and enqueue the next left child. So for that we have to dequeue 5, or which are the next elements, 12 and 13. So with that, for that we have to enqueue 12 and enqueue 13. So that is the second step. And the third step what you have to do, so dequeue the element 12. So here dequeue the element, next element, this is considered as the friend element, so we have to dequeue 12 from the queue and enqueue the next left element, that is 7. So we have to enqueue 7 here. So that is the step. And the next step we have to, from here this is considered as a friend element. So in next step what you have to do, we have to dequeue the friend element 13 and enqueue is left child, which are the left child, 14 and 2 to the queue respectively. So we have to add 14 and 12 to the queue. And the next step, so here the next, so we have to enter 14 and 12. Next what you have to do, 7 is considered as a friend element, so we have to dequeue 7 from the queue, dequeue 7. So 7 get visited, 7 from the queue. Then which are the elements, 14 and 2 already entered into the queue. Next element is 17 and 23, so we have to enter 17 and 23. So next here this is considered as the friend element, so next step dequeue that friend element, that is 14, we have to dequeue 14. The next elements are 2, 17, 23, which are the next two elements, 27 and 3. So likewise the next friend element is the 2. So when you dequeue 2, so dequeue get visitor. So when you dequeue 2, the next elements are 17, 23, 27, 3, 8 and 11. So we have to enqueue all those elements. So next 17 will be considered as the friend element, remove 17. Next 23, likewise similarly dequeue the rest of the nodes. We have to dequeue rest of nodes from the queue until the queue gets empty. Until the queue gets empty, no element here until. So here likewise, so the last element is 11. So here, so finally 11 get visited. So dequeue 11, you will get empty queue. So likewise you have to visit all the elements. So this is the level order traversal. So gate question, let us discuss the gate question. So the question number 1 here. So here in this question, if the binary tree in the figure is traversed in order, then the order in which the nodes will be visited is. So here this is a tree, so in which we have to figure is it is traversed in order, then the order in which the nodes will be visited. We have to find out that. For that we move to so here, as you all know, since it is an in-order traversal, we want to move from left, root, right. Leftmost node, root and the right. Root and right. So left, root and right. So here since it is an in-order traversal, so and another thing in that question, since it is a binary tree data structure, so it's a hierarchical data structure in which each node has at most 2 children referred to as left child and right child. So having left child and right child, maximum of having two children. So that is the thing. So since it is an in-order traversal, you start from the left. So here this is the leftmost node. So start from G, and the next is the C, and next is the B, and next D. So leftmost get completed, and the next one is the next traversal. You have to visit to the root node. So here A is the root node. A is the root node. So you have to visit at A. Next one, which are the rightmost node, F, E. So the traversal is G, C, B, D, A, F, E. So this is the traversal, in order traversal. And the next question here. So here this is which of the following sequence denotes post order traversal sequence of the tree shown in figure. So here there is a tree. We have to 4 options are here. 4 options are here. So from this we have to identify the post order traversal of the given tree. So here post order traversal, here start from the leftmost, that is the G first. Start from the leftmost, that is G, and next one is the C, and the next one is the D. Since it is a post order, next B. So here completed, leftmost node completed. So the next one is the right, left, right root. So F is the right, next one is the E, and finally we move to the root node A. So this is the root node. So here the traversal is G, C, D, B, F, E, A. So this is the traversal. So here the problem 3, find the DFS design of the tree shown below, that is the depth first search. Here it moves along the depth. So here this is a tree. Here we have to find out the DFS. Here it will start from A. So it will start from A. It will start from A. Here from A, that is A, next to, since it is a DFS, next one we have to move to B, and next one we have to move to D, next one we have to move to C, and next one we have to move, next traversal is towards the E. So the answer will be A, B, D, C, E. This is about the answer of DFS given below. And here find the pre-order of the tree shown below. Here pre-order, you all know that the pre-order is a root left to right. First you have to traverse the root node, next one is the leftmost left, next one is the right node. So here what is the root here? So here the root is A, So here it is the root is A, root node is the A, next one is the left. What are the left? B, D is the left. Next we have to move traverse to the right. So which are the right node? C, E, G, F, H, I. So this is the pre-order of the traversal of the tree given below. Start from the root, next to move towards the left and move towards the right. And next one, find the post order of the tree shown below. Here the post order traversal means the traversal will start from the left side and then towards the right and then towards the root node. So here this is the root and this is the left and this is the right. Here in this post order means first one is the left. So since it starts from left, here it starts from D and next move towards B, and then is the right. So since it is right, then move towards G, E, H, I, F, C. So rightmost nodes completed. So completed. Then we have to move towards A. A is the root node. So this is a solution for post order. So the post order is D, B, G, E, H, I, F, C, A. Finally you will get the answer. So here this is a problem related to get. Here let last post, last in and last pre denote the last vertex visited in post order, in order and pre-order traversal respectively of a complete binary tree. Which of the following is always true? Here last post means last vertex visited in post order. So last in means last vertex visited in order, and the last pre means last vertex visited in pre-order form. So here which of the following is true? Here are some options. First, in generally we know post order last. So post order last means last vertex visited in post order. When you go for a post order traversal, the last vertex visited is root. So that is the thing, root. And when you go for pre-order, the last vertex we have to visited is the rightmost leaf. That is the pre-order. And for in-order last, here the last vertex we have to visited is the rightmost node. So that is the thing for in-order. So the option is, what is the first option? Last in equal to last post. So last in equal last post. It's not possible. Last in, what is last in? Last in is the rightmost node. What is the last post? Is a root. So it's not similar. So we cannot take the first option. The next option, we cannot take the first option. So next option, last in equal last pre. So last in equal, what is last in? Last in is the rightmost node and last pre is the pre-order. Pre-order means rightmost leaf. So surely it will not be equal. So this option is also wrong. And the third option is the last pre equal to last post. What is last pre? Last pre means pre-order last. So since it is a rightmost leaf and the last post is the root. So root, rightmost leaf not equal to root. So this is also not possible. The D option is the none of the above. The correct answer is the none of the above. So which of the following is always true? Above three options are not correct. So it is not possible to get it is always true. So the last option is the none of the above. So that is the answer. That is the option D. Thank you, and we'll continue next class.